Our last one. Let's look at graphing these other three less familiar trig functions. We're going to do one of them here as an example. Cosecant of x. We can sketch the graph. We can't in our calculator. Well, there's a way that we need to be able to sketch it by hand. So this top graph, well, on the bottom graph is where I'm going to sketch. Cosecant of x. And on the top graph, I'm going to sketch sine of x, because cosecant of x is equal to the inverse, or the reciprocal of sine. Okay? So sine, let's start there. All right? I know it starts at 0. It completes one period, pi. And so half of that is pi. And I can just sketch a nice little curve. Man, I'm good at these. Negative pi. And then sketch the same thing backwards. Nice. It has a range 1 to 1. Cool. Let's label this a little bit further. Okay. In between here, it reaches the maximum. It reaches the maximum exactly between pi, 0 and pi. That's pi over 2. Nice. Okay. Also, it reaches this minimum here exactly in between 1 and 2 pi, which is 3 pi over 2. So this point here is negative pi over 2. This is 3 pi over 2. Okay. And I'm going to come down here and label. Just start to label the graph that's about to become cosecant of x. So just getting ready here. Let's see here. Negative 2 pi. Negative 0. Negative pi over 2. Negative 3 pi over 2. All right. So what do we say here? So let's analyze. 1 over sine of x. Okay. First of all, zeros, x-intercepts. It's almost like we're analyzing this a lot like we analyze rational functions, because it is a rational function. Crazy. X-intercepts is when the top is equal to 0. The top is 1. It's never equal to 0. There are no x-intercepts. It never crosses the x-axis. That's huge. That's a huge piece of information. That's going to help us draw it later. Vertical asymptotes, that's when the bottom is equal to 0. So whenever sine of x is equal to 0, there's going to be a vertical asymptote for cosecant. So these x-intercepts for sine are straight below. That's where there's... See if I can do this. It's not bad. And then there's one at 0. Let's see, there's one at pi. And 2 pi. I'll straighten those up. And then one at negative 2 pi. Nice. Get these straight. Well, that doesn't look straight, does it? There we go. Move it over. There we go. Move this one over, maybe. There we go. Looks good. That's straight. Yeah, hard to tell. All right. Let's see here. Oh, what else we can tell from this is that if cosecant of x is equal to 1 over sine of x, then cosecant of x is equal to 1, and sine of x is equal to 1. Because the sine of x is equal to 1, 1 divided by 1 is 1. So sine is equal to 1, cosecant is also equal to 1. Alright, so whenever it's equal to 1, there and there, let's label it as a 1 right there. That's where cosecant is also equal to 1. Same thing with negative 1. Whenever sine is equal to negative 1, cosecant is also equal to negative 1. So you can see it alternates up and down. Alright, now we can sketch this real quick. This is easy because we know it doesn't cross the x-intercepts. No x-intercepts. That's like the whole key here. So if it goes through this and it approaches these asymptotes, it must. That's the worst drawing I've ever had. It must look like that. Okay? Because it can't go down. It can't go down and approach, and it can't go down and cross the x-intercept. So it has to always be going away from the x-axis. All right? There it is. The secant graph is the same thing, just shift That's up to you guys to figure out. All right, thanks.